Hey guys, this is Jim K and 4YCD. You're watching FEP Labs Radio. Thanks for stopping by. So what we have today is a LibreVNA. Now, I don't know if you say LibreVNA or LibreVNA, so I'm going to go with LibreVNA. This is similar to a NanoVNA. It's a low-scale vector network analyzer. A true vector network analyzer is thousands and thousands of dollars. Even an old used model is north of $2,000 or $3,000 generally. So this is similar to a NanoVNA. It's bigger than a NanoVNA, and we're going to take a look at it today. Now this will go from the frequency range on this is 100 kilohertz to 6 gigahertz. It has both ports, S2, or port 1 and port 2 for S11, 12, 21, and 22 measurements. The software is free, available on GitHub. This is based on an open source project by a user named Jankae, Jankae. I don't know how to say that either. So let's talk about it real quick. I'm probably going to do, I would imagine there'll be another video or two on this in the coming weeks. There's a lot to unpack with this, and I don't want to make this a super long video, and I'd like a chance to get to know it a little better than I have already. I've had this only for a couple days. As you know, I'm not a huge unboxer. You know, it's a box with stuff. So this comes with a USB-C cable. It comes with a standard USB-A to USB-C cable. It comes with a USB-A connector to whatever that is, 1.5 millimeter, I think, 2 millimeter power connector. So this is the device itself. We'll talk about the rest of the case candy here in a second. This is the device itself, and as you can see, port 1 and port 2. We also have external reference connectors. This has the power input connector and the USB-C connector back here, as well as our external reference ins and outs. Let me scoot this up a little bit closer to the camera. You can see that we have, and there's probably no way that's going to show up on the camera. There you go. This is a whole line of LEDs that show us different statuses for what's going on, whether it's booting up, it's got power, error messages, what port we may or may not be using, so on and so forth. And these light red or green appropriately as you have the device on. This is made of aluminum. This thing is stout. If Demo Ranch had this, he'd probably shoot it and see how many bullets it could stop. This thing weighs a fair amount. I'd say a good pound, pound and a half. And as you can see, the construction on this is overkill, I think. There's probably a scientific reason for all those fasteners, but there they are. That being said, we're not going to take it apart because that's just way too much work right there. All right, and then of course we have port 1 and port 2. This has a maximum input power of 10 dBm plus 10 dBm at 10 volts DC. So you, like any NanoVNA, like any tiny SA, like a regular spectrum analyzer or regular vector network analyzer, you need to make sure that you limit your input power with an attenuator or a RF sampling device of some sort, which will also have the same effect of limiting the input power. So the device itself comes with two SMA male-to-male cables, and it comes with, it comes with all the adapters, a male-to-male SMA, a female-female SMA, and so there's male-to-male, female, an open, short, and load. There are two female-to-females, two loads, and an open and a short adapter. So what this can give you is a full set of calibration for port 1, open, short, and load, port 2, open, short, and load, through calibration, and then both port 1 and port 2 with a load on them. So you get a complete SOLT, short, open, load calibration setup with it. And it's got little rubber baby buggy bumper feet for it. And then, as I said, the two cables. Now, a couple things that I've discovered about this so far. It says in the documentation that it will run on straight USB. So you could use the standard USB cable and plug this into your computer. And I have done that, and it seems like it works okay. I have not had any problems with that. But it also says in the book that it's potential that your USB port could current limit, and then that's going to cause this thing to give errors depending on what it's doing. So that's why they include the external power. That will run off of any USB that can provide 5 volts and 1.2 amps. So a battery pack, a wall wart, as long as it's a 5 volt 2 amp one, you'll be good to go. Like I said, I've ran it both ways. I ran it straight USB off of a battery pack I had, and it ran fine that way. It didn't give me any grief. So either way will work fine. The device itself runs hot. It gets warm. You can't fry an egg on it, but it's a little heater. I would suggest that if you're using this in an extended session, you stack this thing up on something to act as a heat sink. I don't know if y'all will remember, but I have that cell wave RF sampler that's basically a giant heat sink with an RF connection. I set this on top of that just to help dissipate heat. I would not set this down on something that's going to insulate it, like this silicone mat or a wood table or anything like that. I would set it up where you can at least give it some air, right, as you're using it, because it does get warm, and I've read several articles on the internet that indicates it does heat up. All right, that being said, there is the device. So we're going to jump over to the computer.
Okay, folks. So here we have the LibreVNA GUI application. Now, this is the Mac version. The Windows version looks a little different. They operate the same. There's no, it does all the same stuff. So this app is everything to the LibreVNA. If you don't have the app, the Libre does not do you any good because there's no screen on it. It's not like a Nano VNA where you can run it from the screen with a stylus or that little guitar pick looking thing, or use it with Nano VNA Saver, for example. With the LibreVNA, you have to use it specifically from the LibreVNA GUI app. The app is available for Windows, for Mac, and for Linux. So when we go to look at the app, you can see the menu up here. Okay. So on the app, we have toolbars across the top that show some or part of the functions that the Libre does, and that depends on what we have turned on for toolbars. We have the 4 different measurement ports, S11, 12, 21, and 22. And I'm going to tell you right now, if I say 11, 12, 21, and 22, don't get all mad at me. That's not the way you're supposed to say them, but I'm probably going to accidentally call it that. And I get really tired saying 1, 1, and 2, 1 over and over. So in the display here, where we have these 4 quadrants, you can arrange this any way you want. So if I decide I don't need this information down here, I can go ahead and close that tile, or I can change it to a different kind of plot. So right now that's set up as a Smith chart on this plot for S22. I can change it to an XY and look at some other data, or I can just close that tile. And that gives me a much larger chart on S21 because I closed it. I don't want S21, so I'm going to close it. I'm going to close the tile. And now I have, as you can see, a much larger Smith chart on one side and a large XY chart on the other. Now at this point, I don't have the Libre plugged in. I'm just kind of walking you through the app. At the end of the day, the LibreVNA is a VNA, and it does what VNAs do. So any function of those 4 ports, 11, 12, 21, and 22, it will do. Anything that a Nano VNA will do, the LibreVNA will do. One of the bigger differences is the LibreVNA has a much wider frequency range, and I think it performs some of the functions in a more advanced manner than a standard Nano VNA. And honestly, for me, I never use the Nano VNA with the screen. I always plug it in with Nano VNA Saver anyway, because I don't want to look at that little tiny screen and mess around with trying to touch stuff on the screen. The only time I would do that is if I was using a Nano VNA out in the field where I didn't have a computer handy. But normally I'm going to load the app anyway. So the Nano VNA has three basic functions. Nano or VNA function rather. It has a signal generator with sweep capability, and it has a spectrum analyzer with tracking generator functionality as well. So those are the three main functions. Now, at its heart, as I said, it's a VNA. So the signal generator and the spectrum analyzer functionality is not its primary thing. They work. Is it the best spectrum analyzer or signal generator you've ever seen? Nope. Got a lot of limitations because of the size of the Nano VNA, and that's not its core functionality. But it does do it. And for a lot of things that we would do ham related, this absolutely will handle it. Absolutely. The difference is at some of the higher frequencies, it doesn't perform as well. And, you know, for anything under UHF, that covers everything most hams are going to do most of the time. I know there's ham things that are beyond UHF, but by and large, most of us are fooling around at UHF and below, certainly HF. So anyway, back to the menus. So up here on the menu, of course, we can load and save setups. Now this is cool. So I have set up my charts, and I'm pulling the data that I want off the Libra. I can save that setup. So if, for example, I have a Smith chart and I'm looking at impedance and capacitance, reactance of an antenna, and I've got that plotting on a Smith chart, and over here on the XY on S12, I've got VSWR showing, for example. So I can make that a setup, and I can save that as its own individual setup. So the next time I come in here to use this, I don't have to rearrange charts like I've just, you know, when I deleted those two. I don't have to rearrange them like I did. I can save the setup. So when I load it, I just load the setup I want, and that sets up my charts and my measurements like I've used previously. So very cool. You know, the first time you use it, you'll have to do some setup, but then after that, you just save those off as individual discrete configurations, and then load the one you want. So down the road, you won't have to reconfigure it every time. And I would urge you to do that, because a lot of these measurements are, you know, somewhat complicated setups. Getting the scaling on your graph right, or what you're trying to track, and what the X and Y parameters are on a graph, or what range you want on the Smith chart, or what frequency range you want to sweep, or what you want to analyze with the spectrum analyzer, all that kind of stuff, all would be saved in a configuration setup file. So set it once, forget it, and then reload it when you need it. Pretty cool. I don't have the device plugged in at the moment. And if I had it plugged in, it would show me over here that there's a device plugged in and what the address of that device is, and I could click it and connect to it. You can have multiple devices connected, and that would refresh it. Calibrations. So again, not having a device loaded, I can't do anything with it right now. I can save my calibrations. I can do my calibrations just like you do them on a Nano VNA. I come down here and I tell it calibration measurements. It'll bring up this screen here, and it'll show that there's no info available because there's no calibration loaded. So I come down and I click which one I want to do. Let's do the port 1 short. He tells me what the prereqs are, that I need a short standard connected to port 1 and leave port 2 open. I click measure. It makes the measurements. It saves the date and time and tells me how many data points it used to do that calculation. And then follow through for all the other calibrations you may or may not want to do. If I'm only going to be doing stuff on port 1, 1.1 and 1.2 measurements, then I don't need to spend time calculating throughs and isolation and line and port 2 stuff, vice, and so on and so forth. So that's how you do a calibration. Like a configuration, I can save my cals, so I can load a cal specific for what I'm doing at that moment, which is very cool. And you could do that with the Nano VNA. Unlike the Nano, this is not saving it to memory on the device, so there's an unlimited number of saves I can do for multiple calibrations. I'm not entirely sure why you would do that, but you could do it. And then, of course, the same with the setups. You're saving this to the hard disk of whatever computer you're running this app on, so I can have as many calibration files or as many setup files as I want to have. I have not explored these two functions yet, tools and de-embedding, so I can't really say anything really intelligent about either one of them. So there they are. If someone can tell me what they are in the comments, that's awesome. I can't tell you right off the top of my head. We have docks on this. So it has 3 docks. We have the device log, the marker log, and the traces dock. So the device log is this area down here. And if I had a device hooked up, it shows me a rolling status of that device, what the device temperature is and other operating parameters in real time, and just keep scrolling. I normally am going to turn that off after I've got the device booted up. This is the a marker log. And so when I drop any markers on a trace, then this saves where those markers are. And I know what parameters and everything. And I can save this data to a separate file. So I've got a trace and I have the data that I captured out of the trace saved off to a file for later reference. So that's the marker log. I turn that off and then I'm left with traces over here. I can pause any of these at one time. So if I'm not running a device, if I don't care about some of these measurements, I can just pause them. And so I'd go up there and click that to pause it. And then I don't want to look at it, so I just click the eyeball and those would disappear off the screen. A slightly different way to clear extraneous data off the screen than the way I showed you earlier. And we can do the same thing here. Pause it, hit the eyeball, and it makes it disappear. Now, what it does not do is it does not clear the charts off the screen. It clears the data from showing on the chart and pauses any continuing measurements that are going on. So that's what that does. If we had data on the charts, it would disappear when I click that eyeball. Now, while this is going on, this device runs, and it runs warmish. I talked earlier when I showed you the device about the power. It does pull about 1.4 amps when it's operating. When there is active data acquisition and measurements happening, the power consumption goes up to about 1.4 amps at 4.7 volts is what it seems to be pretty consistent on power measurements. And it will warm up over time. So now we've looked at the docks. Let's look at the toolbars. We have 4 toolbars we can use. There's always one up here by default. So this is our spectrum analyzer, signal acquisition kind of toolbar that's always there. And here's where I'd set my start, stop, center, span frequencies for whatever frequency range I wanted to look at data for. That works just like the LibreVNA does. It works like a spectrum analyzer. I can give the device a start and a stop frequency, and he'll figure out automatically what the center of those 2 freaks are and what the span of those 2 frequencies are. All right. We can zoom in and out on our span by clicking the plus and minus magnifying glasses. Our resolution bandwidth, RBW, we can adjust that on the fly. What kind of windowing function we're using. This does not have all of the windowing functions you typically see in a VNA, but it has 2 or 3 of them. There's probably 6 or 8 different styles of windowing functions, I believe, in my full spectrum analyzer. And what that is basically a data presentation kind of value thing. So this is all the stuff that it does. And this is your basic setup. What port do I want to use for this measurement? And while I have port 1 and port 2, I don't have to use them as S11/12 and S21/22. I can use either port for inbound or reflected measurements. So if we turn on some of the other toolbars, you see we get more things that we can adjust for our, and it goes over here, for our, yeah, now see that's a normalization measurement for the tracking generator, so I don't want to do that, but it won't work. So we can turn all these on, and it gets a little crowded with them on. And one difference I will say is that I like the Windows version of the software seems to present the screen a little better, a little clearer about what functions are attached to the VNA and what functions are attached to the signal generator and what functions are attached to the spectrum analyzer. On the Macintosh version, it doesn't really separate them out. You kind of have to know what you want to change for what function you're trying to do. And so it's a little weird. Again, on the Windows version over here on the side, there's spectrum analyzer, signal generator, VNA, one button for each. And when I click that button, that's what I get on the main display up here at the top. So pretty cool. And again, you know, they both work fine. It's just a matter of you have to dig a little deeper to find the functionality. And I don't know why it is that way. There's no Macintosh reason why they did it that way. No Apple reason. I guess it's a couple of different sets of developers, and the Apple guys just did it differently than the Windows guys. I haven't looked at the Linux version, so it may be even more different. All the stuff is here. All the functionality is here that's on the other versions. It just presents those buttons a little differently than it does on the Windows version. But I'm sitting at a Mac right now, so we're running the Mac version. So I talked about all of that, and that pretty much covers the application basics. You can come in here. So for example, on any of the graphs, whether you have one up here or two up here, and we're going to go to one here in a second, but like on our Smith chart, we can limit the display mode to the current span that we have set, or we can pull a Smith chart to show complete traces. So however which way we want to do that. So you right click and then you can edit parameters. And this Smith chart is currently set for S11 parameters, or I could change it to S22. We're going to close it now. I can add more tiles if I want by clicking vertical and horizontal, so I can have numerous graphs up here at one time. And let's say we want to split this guy up. There's probably a limit. Yeah, looks like there's a limit. Let's do a vertical there. Let's do a horizontal there. Look at that. We can get crazy with how many different graphs we can run simultaneously. So the limit of this is going to be your compute power and the VNA. I don't know how well it would operate if you're trying to assess 6 or 7 measurements at one time. And so we can close all these and go to one specific graph. And so we'll just show the XY here real quick. And in here, this is where I could add markers, and they would show up down in that dock if I had that dock turned on. This shows what parameters are available for this particular graph. And then here we can set our x-axes, frequency, time, distance, or power, for our x, our right-left horizontal graph. And then we can have two y-axes, two separate individual y-axes. So on the primary one, for example, if we're trying to measure SWR, it would be our SWR reading. And then say the second one is phase. Let's use phase. So that's what we would see. So potentially this would be an SWR chart, something like that. And then a phase chart as it is in relation to SWR. It will measure the secondary y-axis over here on the right side. And of course, the primary axis is over here on the left. You can manually set your scales for each of your axes, all three, the primary Y, the secondary Y, and the X at the same time. So one thing I've discovered is that there's no stupid filter on this. So if I make a typo and set some retarded scale that puts it off the screen or just not realistic, that I can come back and I can click auto and it will unscrew the craziness and put it to sane values where my data is back on the screen being traced. So that is super neat. And as I mentioned, if I want more graphs, so I've been, graphing SWR and magnitude, or phase rather, and I decide I want to pull up a Smith chart of an antenna. I can come down here and I can say close, but then I can say, give me a Smith chart. I can do the same thing, say close, and I can say, let's do a split tile, horizontal. Let's make you a Smith chart. Let's make you an XY plot. And so we're back to what we had before. And here's my XY with 2 Y vertices and a single X. And then here's my Smith chart. And these parameters can be set obviously completely independent of each other. So that about covers it in a nutshell. With the VNA device itself is an excellent piece of gear. And as I said, it's very well constructed and seems to work quite well. I'm pleased with it. I'll probably be offloading both of my Nano VNAs. This is a solid piece of gear. And I'll have some videos coming up in the future. I'll do some measurements and stuff with it. But I kind of wanted to walk through the software and show you the device. And that's, I think, all we're going to cover in this particular video. So guys, I appreciate your time. I hope you're still with me and I didn't put you to sleep. If you like the video, give me a thumbs up. Make sure you're subscribed and ring that bell so you get notified whenever I post any new content. And we can feed the YouTube algorithm so you know when I post any ham or ham adjacent videos. Fellas, thank you all so much. 73.